Okay, it's the new year, and I think this plastic has cooled down enough. Let's see what we got. Okay. More. You can hear it popping loose from the side. That's good. We get some pliers. The can will have to be victimized in the process. Okay, there we have it. It shrunk quite a bit. There's also quite a few holes, but we don't need the full diameter for most of the part. So, yeah. Still 11 centimeters left after facing and doing all the other operations. I think I may have a piece that just has the right size. Not too much to spare, but okay, there we are. I've checked the piece up in the lathe. Yeah, we're going to turn the outside to a diameter of 50 millimeter and face it at about 10 centimeters. And then we're going to bore the inside so that it fits over the central hub. Yeah, in the process we will lose more than half of the material that's on this. So what I have done is I've put a cloth under the lathe, under the bed, and I hope that that will suffice to catch most of the swarf so that I can remelt and reuse that. Okay, stage 1 is to face off. I was somewhat afraid that this would not be sitting solid enough in the lathe, but as it is for now, I think we will still be okay, although it is protruding quite a bit. The piece is too big to fit into the chuck, so this is all I have, the best I can do. Yeah, I think at least for now we are fine. We will see how it goes when we reverse it, because the order of operation is I will do everything on this side, face it, turn it to length for as far as I can go, then reverse it, clamp it again, and finish the other side, which also has an edge at the end, which is intended to keep the filament from rolling off on that side. So yeah, let's start. That was 1.5. Let's see where that got us. As far as the overall length is concerned, (106), 107. I have to make it fit on one side or the other, so best to take off a bit more on this side. The other side looks much better because it was in the bottom of the can. That is always the case when you melt plastic like this. The bottom part is generally the best. So we'll take off a few more millimeters. I think I'll go till like 10.2, something like that. Okay, that was another 2 millimeters. (104). I think it was a good decision to collect the swab from this one. (102). Oh, sorry for that. I think I'll stop here because the other side may need some flattening out as well. So I still have some space for that. So that means we're through with this. As you can see, there are quite a few holes in here, but as usual they are in the center, and that's the part we will cut out. So I have no problem with that. Next phase is to machine the outside to size. And I've decided that 50 millimeters will be a nice size for that, because most spool holders for filament are fitting on that. So 50 or slightly under. I'm shooting for 50, of course. And then yeah, you see how it looks. And then I mean the surface, of course. The first few passes will be yeah, what shall I say, pretty rough, because as you perhaps have seen, the part is not 100% center straight. It has a slight bend, so I think it will have it will be a few cuts before it cuts nice and evenly all around. We'll go with half a millimeter per side. Okay, let's start. small center hole. Reducer speed will go in with the 16mm drill next, and I'll try to bore almost through, or perhaps even completely through. The inner hole will have to be drilled from one side to the other, and the drill does have the reach to do that. I'm not so sure about my boring bar. I think with the boring bar I will go in until, well, half or a bit further perhaps. Okay, I already didn't like how this was going, because you can see the drill clearly moving up and down. That means the hole is not finding the true center, probably due to irregularities in the material. So and then it wiggled itself out of the Morse 3 taper, so I had to stop drilling. This means this is as far as I will go from this side. We will clean it up further with the boring bar. Okay, I've taken the camera in my hand for just for a quick word regarding my setup with the boring bar. I have a nice rigid boring bar, which I use mostly for aluminium, with this carbide tip that's in it. It's very sharp and it cuts well, so it should do well for plastic also. To make this boring bar seat properly, I have laid some aluminium, and this is an angle piece, under the boring bar, and from the front side you can see that the angle rests against the tool holder, which means that it gets a bit more offset. Normally the tool rests against that shoulder, and then it would mean that the bolt to fasten it would not be straight above the center of the tool, and then it's not. It could be that it's not rigid enough. The overhang of the tool, I have put it such that it has just the overhang that I need to get about halfway, so that's hereby decided. Then I'll have to do the same thing from the other side. There we go. And that's that. Okay, let's see if this setup is really rigid enough. And for this job, I've also installed my homemade carriage stop, and I'm going to set it to the correct depth now. As you see, I have already put it such that the carriage is sitting against the carriage stop, so it cannot move forward any further. Then I have the tool. It's touching the front of the work, and what I'm now going to do is with the yeah, that thing of which I always forget the English name. It will dawn on me shortly, but sorry for now. We're going to set the depth. I've set this dial here to 0 as well, and one full rotation gives me 2 millimeters. So I'm doing 1, 2, 3, 4, 5. So now the tool is 10 millimeter in. Now I'm not touching this anymore. I'll simply move out the carriage, and I can do everything with the carriage by hand until it stops when, of course, when I touch the carriage stop. So that's how we'll go about this job. Okay, camera back in the holder, like so, 360 RPM. There we go. That's not 360. So now it's time to take out the carriage stop and make sure that the whole internal hole diameter is up to size to receive the central hub, which means I need 25 millimeters or more. I think if I look into that hole, that there's not very much to take, but anyway. Okay, so we are ready for the next stage, which means machining this shoulder back to about the width that I wanted. In order to reduce the risk of the workpiece breaking, I have put in the dead center. In this case, a dead center because this plastic is slippery enough, and it's the most solid. And also it takes less space, of course. What you cannot see on camera, but still is the case, is that actually the tailstock is also operating as a sort of carriage stop, because and the way I set it up is that if I'm turning the carriage back, then it cannot go farther than you see now, because then it's hitting the tailstock. So that's another way to protect yourself from cutting too deep. Of course, we will only use manual feed with this sort of setups. So, same RPM, let's see how it goes. Okay, we're ready for the next step. Finishing off the backside of the outer roller. I'm leaving the dead center in place to increase the rigidity. Other than that, it's pretty much the same as the other one. Okay, slightly different approach than for the other side. I will take a smaller drill first and then increase the size. I think even in 2 steps. All of this to reduce the forces on the workpiece. Here we go. Okay, time to see if our central hub will fit in. Well, that slides pretty easy, so I'm happy with that. Next step is to create the shoulder on this side, where, as you can see, we have much less issues with holes than on the remainder of the part. That's generally the case with melts like this. The bottom always tends to be the best part of it. So I'll get set up with the boring bar again, and we'll do this second shoulder. Okay, that's set up. I've done the same trick as on the other side. So I've installed my carriage stop. Yeah, you can just see it over here. And put the carriage against it while the tool was facing or touching the work, I should say, and then I turned inwards 10 millimeters with my dial, and yeah, that means the depth of this cut is now set to 10 millimeter, which is the depth I need for this bearing. So now it's a matter of making it the size, 32 millimeters. Here we go. Okay, here's the finished project, or the finished product, whatever. Yeah. So you can tighten the nut here so that the axle does not rotate anymore, and still it moves freely. And I can just loosen them now manually and see how it goes with filament. Okay, I can tell you this is much better than before. So my printer will have no problems anymore pulling off the filament from the roll. Yeah, I may decide to create another external roller because of the holes. It's not pretty, but it does not in any way prevent this thing from doing what it has to do. What I may want to do is machine another ridge to go on here so that the filament is not able to slide off, but it can't get off anyway because the holder prevents it from doing that. So I think this is what we wanted.